Find the largest number obtainable as the product of positive integers, whose sum is 1976. This is problem 4 from 1976 International Mathematical Olympiad. Let's consider how to get the solution. The challenge is to find the optimal way to split the number into smaller components. We analyze the smaller number first and make some strategy to get the optimal result. Let's consider 2. It can either remain as a single 2 or be split into 1 plus 1. Clearly, the product 1 times 1 is less than 2. As we want the greater number, it's better not to split 2. For 3, it can be split into 2 plus 1, but the product 2 times 1 is less than 3. So keeping it as 3 is better. We also observe that splitting a number to include 1 is not useful, as multiplying by 1 doesn't increase the product. Now let's consider 4. If we don't include 1, 4 can either remain as 4 or split into 2 plus 2. In this case, 2 times 2 is 4, which gives the same result, so either option works. For 5, it can be split into 2 plus 3. This results in 2 times 3 equals 6, which is larger than 5. So splitting 5 into 2 and 3 is better. The key observation is that for any number larger than 4, splitting it into smaller parts gives a larger product if we don't include 1. It is advantageous to split it into 2s and 3 since their products are greater than the original number. So we have to consider splitting a number into 2 or 3, which is better. Let's look at 6. 6 can be split into 2 plus 2 plus 2, or 4 plus 2, or 3 plus 3. 2 times 2 times 2 is 8. 4 times 2 is also 8. 3 times 3 is 9. So splitting numbers into 3s as much as possible tends to yield the largest product. The number 2 is used only when necessary. Now we have a strategy to get the maximum product integers summing to a large number. Avoid 1 because this reduces the product. Maximize the use of 3 as it consistently gives the highest product. We should aim to split the number into as many 3 as possible. When dividing by 3, there may be a remainder. Based on the remainder, we adjust the final split. If the remainder is 1, we avoid using 1 by combining one of the 3's into 2's, since 3 times 1 equals 3, but 2 times 2 equals 4. If the remainder is 2, we simply use 2, since 2 maximizes the product in this case. Now we divide 1976 by 3, we get 658 and the remainder is 2. This means we can split 1976 into 658 parts of 3 and 1 part of 2. Thus the largest product is 3 raised to the 658 times 2. This is the optimal solution, and it ensures the product is maximized by following the splitting strategy we've outlined.